If you have been doing CP for any amount of time, you must have seen submissions with code like this and must have wondered what is wrong with this person and why does he clutter his code like this? Well, a lot of things are wrong with me really, but that aside, the reason I clutter my code is because it is convenient. Because what this code does for me is define some commonly used functions like LCM, modular exponentiation, or just make it more convenient for me to deal with CP problems like being able to input an array like this and a matrix like this. This can also be used to shorten verbose parts of the language to make it faster to code during the contest. Some deranged individuals take it a step further like this, but I ain't one of them. This is the reason why I and many other people use some pre-written code in all their submissions. This is commonly called templates in CP, not to be confused with the template feature of C++ language. That is a different thing, but it is used in building the templates of CP. So by now you must be wondering, okay, templates sound very convenient, but what's the best template? And the answer to that is my template is best, but for me only. I'll explain my template in a second, but what I wanted to emphasize here is that people often look at other huge templates of better programmers and think that they should copy all of it. And I think it is a bad idea because templates shouldn't define how you code, but the other way around. So, how exactly you should build your template? Well, I would suggest you start empty and as you solve problems while practicing or in contest and realize that okay, this thing is being used a lot. I might want to add it into my template, then add it. Or if you find something useful in others' code which can help you, then add it. Or if you learn something new and think that it can improve your code. So, my point is incrementally build your template and it will be very useful to you. Okay, so now my template. So this is my CP template. It is pretty big, 173 lines, and this is what I'll be explaining. So this is hash include bits stdc++.h. What this does is includes all the C++ standard headers so that I can use anything without having to separately write its import. So like if I need to use vector, I would need to do hash include vector, but I don't have to do that because I use this. I touched it a little bit in my good practices video. You can check that out as well. Now this is a header I use for stack allocation. I will get back to it later. These two headers are for policy based data structure. If you don't know what that is, I mean, I think there are more than one, but the one I use is ordered set, which is defined here. These are commented out right now because I use Clang compiler right now because I'm on Mac. I also have GCC, but I use Clang because it is faster to compile. So if you don't know what policy-based data structure are, the ordered set is a set where you also know how many numbers are smaller than some certain number. So it also stores the rank of the given number. It is useful in some problems. You can read more about it here. And as you can see, this is me templating it. And yeah, after that I have using namespace std. So what this is, if you don't know what namespaces are, so basically let's say there are the standard developers and what they have made is they have made a function called gcd, okay, which they have made. But now let's say some other library also defines their gcd function, but it does something else, and now you can see there are conflicting names. So what is done in C++ to avoid this is we surround this with namespace, so std. And using this, now these two names won't conflict because to access this we have to do gcd, and to access the other one which is inside the namespace we have to do like this. And this namespace, and to avoid doing this every time, because in CP we are only using the standard header files. So what we do is we say using namespace std And with that, we don't have to do it anymore because it just removes the namespace. I mean, not technically, but you can assume it like that. Similarly, we have to use this namespace for using policy-based data structures, GNU PBDS. It is also described here. And like I said, it is commented out because I don't use it right now. Then these are my pragmas. These are for some lucky code optimizations. If I write vectorization friendly code, I touched it a little more in the good practices video. I'll link that. Now these are my aliases. So let's say I want to use long double, right? So I won't say long double x is equals to 5.0 everywhere. I'll just say ld x is equals to 5. So this is convenient and obviously helps to write types faster, which don't really matter that much. So that's why I use them. And I use the using keyword in this because modern C++. Then this is the PBDS again. And then I store some constants. So in many problems, having a very big value as a representation of infinity comes in handy. And similarly, in many problems, having a very small value as a representation of epsilon comes in handy, which is epsilon. And then a lot of problems require answer modulo some mod value, so I have that as well. And these are const expressions, as you can see. So the difference between const and const expression, right? So the difference is they both are constant, but this value is assigned on the runtime, and this value is assigned on the compile time. So const expression is better. Then I have a few macros. If you don't know what macros are, it basically means what this line will do, right? It will replace all the syntax occurrences of this thing that is first with all the syntax occurrences of capital F with first, and all the syntax occurrences of capital S with second. So let's say I had a pair, right? Pair into the integer x is equals to 1 comma 2. Then to access the second element, I would have to do x dot second, right? But what I can do now is x dot s. So just to type faster. Similarly, I do all x so that when I have to sort, I can just say all x. And then I also have reverse one. I don't really use this that much. And then I have define it long. So what that does for me is because I have a habit of writing integer, what this does for me is replaces it with long, so I avoid integer overflows. And because I use 64-bit architecture, sometimes it is faster, I think. I'm not really sure. Then this is a struct functor, I think. So basically, as you can see, we have this operator defined here. If you don't know operator overloading, what that means is in C++ is, let's say there are two pairs, right? Let's say you're treating pair as a coordinate, okay? So you have x and then you have y. Then you cannot do x plus y, right? But you semantically want x plus y to mean something. That is x dot first plus y dot first is the new first, and x dot second plus y dot second is the new second. So what you can do is you can tell C++ what to do when you use plus with two pairs. That's what operator overloading is. I kind of went on a tangent here. This was very irrelevant, really. So what this custom hash does is define a somewhat random hashing, which is not hackable, because many times people blow up unordered maps. So what we can do is we can use this custom hash to avoid that. It is explained in this blog, so you can check it out. And so yeah, I have defined this like I was using alias here. I am also using alias here to say safe map. So what I can do is I can say like safe underscore map of int x, and then I can say this. So just like normal unordered map, I don't have to specify the custom hash every time. And then I have the operator overloads. So these are great. These are very useful. So you must have seen that what I do a lot of times is, let's say I have to input an array, right? what I do is I just define the array and then I take it as input. And why this work is because of this function. So just now I explained what operator overloading is, right? So cin is a type of istream. Okay, so what this operator overloading is defining is what happens when you cin a vector. Okay, when you cin a vector, as you can see, the first parameter is istream cin, operator is double less than arrows, and the right operand is a vector. Now vector can have any type in it, not just int. So what I do is I just iterate the vector and take it as input. So this works under the assumption that the type t is inputable. So, and as you know, this type int is inputable, so this works. Similarly, I have defined how to take input for pairs. So what I can do is I can say a pair. So let's say I wanted to take a coordinate as input. So I can just do this and it would work. So this is what this does. Again, an input stream, a pair, and then I take input. Again, this is under the assumption that both the types specified are inputable. And what inputable means is that this operator is defined for them with istream. And what is a cool thing about them is that they can actually combine together as well. So let's say I wanted to take input of n coordinates. I could do it like this. And I can also, kind of recursively use those functions. So I can take in a matrix as input like this. And then there is the cout for the same pair and vector. Just like cin, we also want to print. So I have cout defined. And this is similar to that. Just we use ostream here because cout is an object of ostream. Now I have some utility functions. So this is my very useful utility function print. So you must have noticed I don't really use cout. The reason is I have defined a print function which works like Python's print function. So let's say in Google Kickstart I wanted to, what we have to do is we have to print like this case hashtag test case and then colon and then let's say some value, some result, which was let's say 1. So instead of doing cout, I can just do it like this and this works. Let me show you. Where is CPA judge? So let me call it for 5 test cases, and as you can see it does it. So what this does is it is also like console.log from JavaScript. So it outputs all, it prints all the things with a space in between and an end line in the end. So very similar to console.log, but this works as long as all these things are inputable. And what inputable means is a cin operator is outputable, and that means is this operator is defined for them with this cout thing. And how it is defined, I won't get into too much detail. It is variadic function templates from C++ 17, I think. So what's happening here is I'm taking any number of inputs using this syntax. I first of all output the first parameter. Don't worry about these double ampersand. This is universal reference. It is a cool concept. I can explain if anyone wants, but that would be going on a tangent, so I'll refrain from that. And then what we do is we print all the remaining inputs, and we keep doing that until we have only one input left. And when we have only one input left, we output it and we print a new line. Okay, so that's my print function, and it is very versatile and very useful. I almost always use print function. Pretty much never have to resort to cout anymore. All right, then I have this size I function. This is basically, you know how many times we loop like this. A is a vector. Now there's a problem with this code, and that is a dot size is actually a signed integer. If you see it, okay, vector integer a. Okay, intelligence won't work here, but this is of type size t, which is unsigned integer. So when you, and if it is 0 and if you subtract 1 from it, it goes mad, and this loop goes whack. So you don't do that. So to avoid that, what I do is, instead of, what I thought I would do is size ia instead of like this. So I wanted to make it a practice to call this function, but I don't, because I'm lazy. But that is what it does. This is static cast. This is just like, saying a dot size and then casting it to integer like normal. But I use static cast because I wanted to feel fancy. Then I have some useful mathematical functions. The first one is GCD. People ask me why I still have it, and the reason is the underscore GCD function, which is this one, right? So this function, okay, this is iterative. This is awkward. So okay, what I used to do is I used to use so I used to use Clang, and in Clang, this is numeric diff. Yes, in Clang this is recursive. So I thought I'm being smart, but turns out I'm not. But I'm too accustomed to using this function now that I don't bother anymore. So you can ignore this. Then I have this GCD extended function. This is the GCD extended thing in CP algorithms. What this does is, for two integers a, b, it returns not just their GCD, which is, let's say, c. It also returns two integers x and y, such that this satisfies, where c is the GCD. It is sometimes useful, like in modular inverse. Then I have the LCM, because LCM is not defined. Then this is binary exponentiation, basically finding x to the power n modulo m in log n time. Then I have modular inverse. When m is prime, I can just say x to the power m minus 2 mod m is the mod inverse. I'm talking about multiplicative inverse, obviously. Then this is RNG. So in some difficult problems, we need some randomized algorithm to solve it, and for that we need a uniform distribution of random numbers. So what this does is it gives me a random uniform number. First of all, I have to initialize the RNG variable, and then I have to call this function. I've only ever used it once, but I kept it in my code because I used it for some problem setting once. Then this is the stack code. So the story behind this is, once CodeChef was not working like normal, and they said that the stack size is currently very small. So if you want a big stack size, you can use this line of code, and for that I needed this import. So that's the story here. I should probably remove it, I think, and then obviously you should subscribe. And then these are my flags by which I compile locally. So if you don't know what these flags are, using C++17 or O2 optimization, defining a local project, define, avoiding shadowing, then some C++ container debugging headers, and then some sanitization of address and undefined operations like 0 by 0. You can read more about them in this blog. It is very useful. And then this is the code structure. So I have a main function where I first of all call these two lines for fast input IO, and then I set precision, because many times we output double and they are outputted like 2.000, but something like 2.986. okay, but we want it up to this much precision. So to avoid getting called wrong answer, so I use 12 precision and fixed, so that it is after the decimal place. I think that's how it is, I'm not sure. Then before solving for every test case, I just call the pre-solve function, where I can do anything that is common to all solve functions, like initializing the RNG variable or allocating the stack. And then I take an input number of test cases, which I can comment out whenever I don't want to do this. And then I call the solve function where my actual logic goes. So yeah, that was my template. Hope this video was useful. There were a lot of concepts I didn't go in depth of, like these universal references. Where is this? Yeah, this is very cool, and perfect forwarding. This is also cool. Variadic templates, and then operator overloading. There are a lot of more use cases, and maybe I will make a video. Leave a comment if you think I should. And I think that's about it. Constant expression is also a very huge topic to discuss, but that was it for this video. Hope you liked it, and bye.